enough people. There's some updates on your AP exam. The school hasn't decided just yet on what it's going to do, but there's like 3 administration windows. First one I think is in-person paper exams, which I don't think the school will end up picking. Then there's like the in-paper and also the online option. And there's the online only option, I think. We'll see what happens, and there's a chance you may have to take your AP test after school ends. If we pick like the really late window, it goes into June, and school ends like June 2nd or something like that. So we gotta wait and see what the school decides on doing. I think the only 2 AP exams that can't be done online are AP Japanese and AP Chinese. They require special software, I think. More on that soon when the school decides. That's all the updates I have for you on AP exams. As for this class, what's due this week is just your weekly reflection. Clear? So if I go to Google Classroom, this week just a reflection. It's a short 4-day week. And then the following week, it's another short 4-day week. We have a 4-day weekend coming up. It's nice. So just your reflections, dude. This week, you can get started on your next 2 assignments. The Coding Bat Recursion 1, this was posted last week, but it has since been updated. So for the 3 people that turned it in, you want to look at this problem set again. It's been slightly modified. To give you enough time, this is going to be due next Friday. And we'll go over the first problem set today in class, and hopefully you can knock out a couple more recursion problems today in class. Your next coding assignment builds on Sierpinski, kind of. You're creating your own fractal, and there is lots of room for creative liberties here. Wednesday for this class, we will launch this assignment and talk about how to get started and stuff. But if you want to preview what's coming up, you can take a look at all these pretty examples of student work, read through the prompt, and kind of mess around. Any questions on these logistics, what's coming up in the class? Okay, while I'm here, if ever you do miss class, be sure you're watching the recorded lecture playlist from here. And let's get started. Went over these announcements. I'm going to paste this link into chat so it's easy for you to access. This should link you to Coding Bat. We'll be working on the first problem called bunnyEars. Problem statement is pretty simple. You could solve it really easily with a loop. The challenge is, how do you recursively solve this? How do I use recursion to figure out the number of ears are present given a certain amount of bunnies? Okay, no loops and no multiplication. You got to do addition, I think. So, oh, it's not even linked. Well, I meant to have it as a hyperlink, but Zoom didn't like it for some reason. Let me try this again. How is this? Be sure you also sign in. Now, there we go. That's better. Please sign in, and for ease of access, click on the link here. Links you to the coding map problem. I have a couple of slides to get you started. We'll pause for like 3-4 minutes for you to type it up, and we'll review the answer in detail. And then give you a couple more tips on how do you code recursively. Okay, for those students that just joined, we're working on the bunnyEars problem from your Coding Bat problem set due next Friday. Alright, so you know from recursion, from what we've learned last week, that every recursive function needs at least one base case and one recursive case. So you can begin to fill out already a little if statement in your coding bad problems. If that's going to be your base case, you're going to do something. Then in the else statement, that's going to be your recursive stuff, and then you do something special, probably a function call to itself. So in greater detail, what would the base case be? What number should go in these orange question marks here if bunnies, number of bunnies, equals something, return something? What do you think? Something to try out, run it, and see if you got the test case correct. Just do the base case. You should be asking yourself, okay, if I have this amount of bunnies, then I know there are blank number of years, or ears. So once you got that test case going, you can then try out the recursive part. Each time you have another bunny, it has a new number of ears added, plus the ones that came before it. So here's your little bit of starter code if you need some help getting started. I'm going to pause the video at this point, give you time to work. If you can give me a thumbs up in Zoom. Alright, you've worked on coding. Hopefully you filled in the blanks here, these question marks on what should go where. Here on slide 80 is the answer. Ta-da! So in the recursive case, you have no bunnies. If you have no bunnies there, then there are no bunny ears. You may have thought it would be 1. That could work too, but I think one of the test cases explicitly shows you when you have 0 bunnies, you have 0 bunny ears. It could work if it didn't address like no bunnies. N equals 1 returning 2 could be okay, and then that's like your classic off by 1 error. The recursive part down here we will review. Each additional bunny adds two ears to your running total, right? And where you're currently at depends on how many bunnies came before you. I guess that's one way to say this recursive part in plain English, right? Recursive, if you have 3 bunnies, it's 2 ears plus the amount from having 2 bunnies. The amount of ears in 2 bunnies depends on 2 plus the number of ears in 1 bunny, so on and so forth. That's why it's n minus 1, counting down in this case. Any questions on bunny ears while we're here? None? Okay. So you're using recursion now, and you kind of think about, okay, when should I use recursion? You know that all these problems could be solved with loops, but is there a case where like recursion's better? At the moment, I don't think we're ready for choosing like the better recursive solution. Just know that it's possible, and we're trying to like work on the recursive part of our brains, develop those muscles. So even if it seems a bit more tedious, it's just for your practice. And later, hopefully you'll see like, like when we work on either Minesweeper or thinking about making a modification to the Minesweeper assignment because it's kind of hard for distance learning. The game of life, could there be parts that can be solved recursively when problems depend on a smaller versions of themselves? Okay. So specifically for the bunnies, you're thinking about, okay, if you're going to explain to someone how to count the number of bunny ears, right, there's kind of 3 choices on how you would explain it. Part A, or option A, you go through all the bunnies at one time, counting 2 ears on each. Option B, use the formula, number of bunnies times 2. Or part C, Option C, count 2 for the ears on this bunny plus the total number of ears on all the previous bunnies. Depending on your choice on your preferred explanation, kind of lends you to like 3 different ways of coding up the answer. All are valid. So if you answered A, right, it should be suggestive of a loop. Encounter a bunny, add it to a running total. I guess this one would be considered like starting at the bottom, going up, right? Counting at 0, going up to n, bottom up solution. If you answered B, you're utilizing your math knowledge a bit more. You have a formula. So it's just one function to solve it, one return statement with a calculation. And then if you answered C, you've really caught on to recursively solving things. That's your recursive solution, depending on what came before you. I guess C right now is like the hardest one to think about. So some examples of where recursion appears. Here are some classic problems that are elegantly and easily solved recursively. You've heard of the Fibonacci sequence or the Fibonacci numbers. That uses recursion, that series. Factorials, that one also uses recursion. 5 exclamation mark, right? 5 factorial is 5 times 4 times 3 times 2 times 1. 6 factorial is 6 times 5 factorial. Dragon curve is a nice little image. Binary search is one of the quickest ways to look for something in organized data that uses recursion. Towers of Hanoi. I really enjoy this problem, and you've seen it before. You may have had this toy that's based on this problem. So, show you a picture, right? Do you recognize these rings? Did you have such a toy when you were a young child? Yes? Like these little donuts and 3 pegs? Maybe, maybe not. Yeah. So this thing is a really neat problem, right? The goal of it is to move all the little rings onto the opposite, like the farmost peg. But the rule is you can only put rings such that like the smaller ones are always on top, right? You can't put a bigger one on top of a small one. You have to respect the size. So this problem is like classic recursion. In my CS like 101 class, our recursive program was to have the computer spit out how you would move the rings to solve the Towers of Hanoi problem, given like 3 rings, 4 rings, 5 rings, like 100 rings, so on and so forth. This is classic recursion. Like you think, why do they make it a kid's toy? They want you to grow up to be really big-brained people. Fractals are really neat. We can do a quick Google search of that. We showed you a couple fractals in the very beginning of our PowerPoint slide, and let's see what Google Images shows us. Yeah, so some pretty neat designs. This one is a special pattern. I forgot. It has a name for it though. Yeah, and you have all these other cool designs that appear in nature, surprisingly. So you could be inspired by this for your original fractal design. Oh, look, your favorite broccoli is recursive. Isn't that great? Okay, so they're pretty neat. We'll go over some common pitfalls with recursion. Take a look at this code. Can you find the mistake? And please type into chat if you do see the mistake. And then can you describe it using words? What happened there? What did they do wrong? They're very close. Very good. A student notices this causes Stack Overflow. What's wrong with their thinking, right? Good. The answers are trickling in. So students are saying it never hits the base case. It creates an infinite loop, otherwise known as Stack Overflow or recursion. It keeps asking bunny ears of n. It doesn't decrement. There's no movement present. Very good. So there's no progression. You never move closer towards the base case. There's no -1. I'm glad you all see it. So you're stuck. The computer just asking, okay, if I want to figure out the number of ears and with 5 bunnies, you just keep prodding yourself. I gotta think, how many ears are in 5 bunnies? How many ears are in 5 bunnies? So on and so forth. Kind of like us mindlessly prodding at the same math problem with no new inputs, right? So this is what you would think, -1. That's the correct answer here. And it could be +1 sometimes, or -2, or divided by 2 times 2, some kind of change in your inputs. Here's another common mistake. Take a look. Can you spot it? What's wrong with this code? Very good. One student has got it. Nice, nice. Yeah. Many people are answering there is no return statement, or missing of the return keyword. Good job. I find the return keyword kind of like hard to describe. We've shown you the return keyword. It reports back to whoever used the function, right? And I feel like that's as much as I need to say. And then you practice this a lot. You always use return in your coding back problems, and you just kind of get it. Like I try to think back in my own instruction on, was I actually taught what the return keyword does? And like, yeah, actually I was. They gave me one sentence. Return returns. Describing it without more practice, I don't know how to do. Last one. Can you find the mistake in this problem? What's happening here? This one's particularly nasty, I think, because you wouldn't get an error of any sorts, but your numbers are always off. Very good. Okay. People got the idea. It's missing the function call. The function is not called again. You remembered the input, the n-1 arguments, but you forgot the recursive part. All these are common mistakes when working with recursion. Given the structure of having a base case, doing something recursively, thinking about how do you move, seems kind of formulaic. You'll be practicing this strategy, this structure in the coding map problem set, hopefully going beyond and being creative with it, messing around to create some pretty pictures in your upcoming assignment. So that's all for today. Go ahead and work on your coding back problem set, look and preview the original fractal. You're welcome to stay these next 8 minutes in the Zoom call if you have questions on coding bat, or just work alongside people in these next 7 minutes. Otherwise, you're formally dismissed. Have a good Monday. It's a Friday schedule today. Last thing I want to say. Friday schedule today. So you're going to just your odd blocked classes. Even blocks are meeting asynchronously. It is not a Monday schedule because you have no school on Friday. Okay, that's all. Formally, you're dismissed.